Lesson 413, Arithmetic Sequences. So this is the last lesson of Unit 4, finally. And it's completely different than anything we've done in Unit 4, so it's a little abstract. So just try to pay attention to it, and I'll get you through it. So, sequences. What is a sequence? So there's a thing called arithmetic sequences. And usually they have to do with lines. So here's the first one. You have Evan. He's saving money to buy a new toy. He already has $12 in the account, and she gets an allowance of $4 per week and plans to save $3 of it in her account every week. So they have started the table off, and you see they use N for weeks right here. So if you look here, N right here, this means weeks. So 1 week, 2 week, 3 week, 4 week. So in the first week, she has $12 already in her account, saves 3, that's where the 15 comes from. Then she saves another 3, 18. So think about this. If she saves another 3, what's going to be week 3? Well, we would just add 3, that would be 21. Okay, fill out the rest of the table real quick. So you would have 24, 27, 30, 33. So here's a new thing for us, a recursive definition. This is how it looks. There's some things that are going to stay the same and some things that you will change over time. So what you do is you start off with A1. What is A1? That means the first term. What is the first term? 15. Right there. A1, 15. And then you write your word and then this funny looking stuff. A of n equals A of n minus 1 plus 3. It also could look like this. A of n equals A of n minus 1 plus 3. You could see either ones, and then you also could see it look like this. A of 1 equals 15 and. Now, I'm going to highlight the things that never change. So all of this never changes. This word never changes. None of this changes. So what does change? Highlighted in a different color. The 15, the plus 3. And where do those come from? They come from, I'm going to draw a little arrow, the first term and what you're adding or subtracting by. So that's all you have to know to write these formulas. This is what we have a hard time remembering. What does it look like so that I can write it? So then they went ahead and graphed this. But our question, letter C, says, what's wrong with the graph of the sequence? Think about connecting all the dots. If you connect all the points, you're telling me that right here exists something, something in here exists, something in here exists. Is she ever putting away money? Because this is our weeks down here, right? Think about it. This is our weeks, and this is our amount of money she has. Does our word problem ever say she's putting away money at 2.5 weeks, at 3.75 weeks, at 4.9 weeks? No. Our sequence says every week she puts money away. So at the whole numbers, 1, 2, 3, 4, 5. So that's the issue. We are only putting away money on whole, that's the important part, weeks. This means once a week, not continuously like the graph illustrates. Because the graph, as soon as you connect those points, you're telling me I put money away continuously every single day throughout the week. No, I didn't. I only put money away every single week, once a week. That's why we cannot connect the points. So now Evan proposes that the formula, it's called an explicit formula. This is different than recursive definition. Look at the difference. See how this one has a of 1 equals 15 and blah, blah, blah. The formula is actually like a line, like a function. And he thinks this is the formula. Test it. How would you test it? Well, you see the letter N here. If we go back up to our table, what does N stand for? Weeks. Could we pick week 1 and see if we get 15? That's how I would test it. So let's try week 1. Week 1 would look like a of 1 equals 3 times 1 plus 15. What do we get? 3 times 1 is 3. 3 plus 15 is 18. $18 on week 1? Scroll up. $18 on week 1? I don't think so. So incorrect formula. Try to think about what the formula should be, because we're eventually going to get there where we try to create our own formula. So just think about it. So now, arithmetic sequences are ones that have terms in a list that increase or decrease by the same amount given. So go ahead, let's click on exercise 2, everybody. So here's our sequence. It says you have an arithmetic sequence is given using the recursive definition b of 1 equals negative 3 and b of I equals b of I minus 1 plus 6. Which of the following is the value of b4? So you want to know what is the value of the fourth. B4 means the fourth form. Now I'm going to get myself screen sketch, maybe. There we go. So that we can try this. So they're telling us, what is B4? Well, I need to find B1, B2, B3 so that I can finally find B4. They give me B1. It's right there. Negative 3. Now remember, what are the two things that change every time you write these formulas? It's your starting one, your B1, and what you're adding or subtracting by. In this problem, they're telling us to do what to get from the first term to the second term to the third term to the fourth term. So I hope you're thinking they're telling us to add 6. So how am I moving from B1 to B2? I'm adding 6. What's negative 3 plus 6? 3. Add 6. 3 plus 6? 9. Add 6. 9 plus 6? 15. I found the fourth term to be 15. That's what arithmetic sequences are. Very simple. Starting term. How do I move from the term to the next? As long as you always remember these are the two important, and this stuff is just basically gibberish. These are the important things. Okay, so you can submit 15 for your exercise 2, and then let's go back to OneNote. Now, let's try to fill in the missing numbers for these sequences. So, arithmetic sequences are relatively easy to spot and are easy to fill in, so to speak. So, for each of the following sequences, determine if it is arithmetic based on the information given, and if it is, filling the missing blank. If it is not, show why. Remember, arithmetic means adding or subtracting by the same number to move from one number to the next. I will do letter A with you, and then you're going to try B, C, and D. So letter A, what I always do is I start off and I say, how in the world do you get from 5 to 9, 9 to 13? Is it same? Is it the same? Is it consecutive? So how do I get from 5 to 9? Plus 4. How about 9 to 13? Oh, that would work. Plus 4. So that means this sequence, every time I go from one number to the next, I'm adding 4. So how would I find that missing blank? 13 plus 4 is 17. So this one is arithmetic. Okay, go ahead. Try B, C, and D. Pause the video and then come back when you're done. Okay, letter B. Did you think this one was arithmetic? Were you able to find the blank if it was arithmetic? If it was not, why not? So start like we did on letter A. How do I get from 5 to 10? Add 5. How about 10 to 20? Add 10. How about 20 to 40? Add 20. So is this arithmetic? No. Not adding by the same amount. We're actually multiplying here. Think about it. Times 2, times 2, times 2. And we'll eventually cover sequences that you multiply by, but not this unit. Okay, for C, did you think it was arithmetic? How do I get from 7 to 4? Minus 3. 4 to 1. Minus 3. So now I need to get 1 to whatever this is. I know that I'm subtracting 3. So 1 minus 3 equals negative 2. So this is arithmetic because we're subtracting by the same amount. For D, how do you get from 64 to 16? That's actually minus 48. How about 16 to 4? Minus 12. Automatically is a no. We are not subtracting by the same amount. What are they doing here? How do you get from 64 to 16 to 4? Think about this. 64 divided by 4. 16. 16 divided by 4. 4. So they divided. And that is something, again, we will cover at a later time. So, last thing. Finding a term in a sequence without listing them sometimes can be a challenge, but not if you take your time and really think about it. So here's our first sequence. The first three terms are 4, 14, 24. 4, 14, 24. Think about it. How are we getting from 4 to 14 to 24? I hope you thought about add 10. So we know that we're adding 10 to get to one sequence to the next sequence. So what is the fourth time? What is the fourth term? Well, the first term is 4, the second term is 14, the third term is 24. So the fourth term, I must add 10, is 34. On the fourth term, which we would write A of 4, how many times was 10 added to 4. How many times was 10 added to 4? How many times do I need to add 10 into 34? Think about it. 10 plus 10 is 20, plus 10 is 30, plus 4. So we added 10. 10 was added 3 times. So on the fourth term, I only added 3 times. On the fourth term, I only added 3 times. So I actually added 1 less than the term number. So if I'm going all the way to the 10th term, how many times am I adding 10? On the fourth term, I added 10 3 times, 1 less. So on the 10th term, I should be adding 10 9 times. So it's 94. This is going to help us create our formulas, our recursive formula, and our explicit formula. Recursive formula, remember, there's things that change and there's things that stay the same. The things that stay the same are a of 1 equals and a of n equals a of n minus 1. This all stays the same. What I'm looking for is what goes here and what goes here. That's the changing items. That's the stuff I'm looking for. So what does go there? A of 1 means first term. I keep writing this over and over again, hoping it clicks. What is our first term of this sequence? Go up. 4. There it is. 4. So we put a 4 there. This one, what are we adding or subtracting by? What did we decide way up here? We were adding by 10. So we write a plus 10. I think the recursive formula is way easier to create because you only need to know 2 things. Now, the explicit formula is where it gets a little trickier. How does the explicit formula work? You must know, so here's the things that will stay the same. That's it. So what changes is, what is your starting term and what are you adding and subtracting by? So let's label these again. So first term, adding or subtracting by. So again, first term is 4, adding, subtracting by 10. So 4, I don't like the way that looks. 4 plus 10, parentheses, n minus 1. So recursive formula, explicit formula. 2 different things using the same information, just in different looks of how it comes out. Why in the world do we use, why are we learning about arithmetic sequences and recursive formulas and explicit formulas? I guess this is the real world situation here. We've got seats in an amphitheater, following a pattern where your first row has a set number of seats more than the last row. So if our first row has 6, so let's underline, first row has 6, fourth row has 18. How many seats does the last row have, which is the 20th? So we're looking for the 20th row. Show your work. So what I like to do is I like to draw like a little visual representation. The first row has 6. We don't know the second row, we don't know the third row, but we know the fourth row has 18. What can we add by, because we know we're adding because we're going up in seats, to get from 6 to the blank to 18? Some people will just use stop and check. say, let's say if I put a 9 there, so I'm plus 3. 6 plus 3 is 9, plus 3 is 12, plus 3 is 15. Doesn't work. So you could use stop and check, or a check and guess, I guess and check, I guess, elimination. Or what I tend to do is 18 minus 6 is 12. So there's 12 seats. Okay. How many times am I drawing my arrows? 1, 2, 3. Divide 12 by 3. So that's number of arrows. What does that give me? 12 divided by 3 is 4. That is what I'm adding by. Plus 4 gives me 10. Plus 4 gives me 14. Plus 4 gives me 18. I did it right. So we're adding 4 to every row to move from one row to the next. So 4 seats. So now, the question is, how in the world do we figure out how many are in the 20th row? The easiest way is to use your explicit formula. What would that look like? Again, look up here, the explicit formula. Things that stay the same. A of n equals n minus 1. So we're looking for our first term and our adding and subtracting by. That's what I need to fill in. First term and my adding and subtracting by. What is our first term? First row has 6 seats. What are we adding and subtracting by? 4 plus 4. Now we plug in A of 20, because it's asking us how many seats are in the 20th row, equals 6 plus 4, 20 minus 1. So the 20 goes where the n is. That's number of rows. That's what n stands for. Do the math. A of 20 is 6 plus 4 times 19, because 20 minus 1 is 19. So A of 20 equals 6 plus 76, 4 times 19. So A of 20 equals 82 seats. So in the 20th row, there is 82 seats. So what to take away from this lesson? You must know these explicit versus recursive formulas, and you must know what fills in, what stays the same. Okay, so I have some stop and check here. You guys have time to work on this. When you are done working on the stop and check, you can go ahead and fill out the exit ticket. And if you have time after the exit ticket, you're more than welcome to work on your 413 assignment.